Good morning, Mr. Chua and fellow classmates. I am Ethan from Group 5, and I will be sharing our findings on the topic of static electricity. To start things off, let's watch an experiment. For this experiment, all we'll need is a tap and a comb. Now, as you can see, while the water is running, we'll slowly bring the comb near the stream of water and see what happens. Nothing. However, if we were to ask Kim over here to comb her hair a couple of times, something amazing will take place. Watch what happens when we try that experiment again. For some reason, the water gets pulled towards the comb. But how does this happen? So before I can explain how the experiment happened, let's go into what static electricity is. So, the whole body of matter, composed of neutral atoms, will be electrically neutral and is said to have zero charge. When the matter comes into contact with other neutral bodies, electrons will not be gained or lost. If a matter loses any electrons from its atoms, there will be consequently more protons than electrons, and it will become electrically positive. When this positively charged body comes into contact with another matter having a negative charge, an electric current will flow between them. The electrons from the negatively charged body will leave it and enter the positively charged body to achieve neutrality. When two bodies having unequal charges are near each other but not touching, an electric force is exerted between them because of their charges. Their charges cannot equalize since the two bodies are not in contact and current cannot flow. This electric force is known as static electricity or an electrostatic force. The fundamental law of physics and electricity is like charges repel and unlike charges attract. Friction, also known as the triboelectric effect, is one of the easiest ways to introduce a static charge. Electrons can be transferred from one body to another during the process of rubbing. For good conductors of electricity, it is difficult to detect a net gain or loss since equalizing current easily flows between conductors. For poor conductors of electricity, it is difficult for equalizing current to flow between them. Therefore, a charge net gain or loss can be easily obtained. Let's take a closer look at the experiment. In the first part of the experiment, when the water was not pulled towards the comb and the water stream were electrically neutral. Thus, no electrostatic force was produced between them. Therefore, the stream was not affected by the comb. However, in the second part, upon combing the hair, electrons are transferred from the hair to the comb. Why electrons are transferred this way and not the other way around is because human hair is higher up in the triboelectric series than polyethylene. This means that hair gives up electrons more readily than polyethylene, and electrons will therefore travel from the hair to the comb. As the comb is now negatively charged, when it is brought near the stream, it repels the electrons in the water, making it positively charged. As there is a resultant attractive force between the positive charges in the water and the negative charges in the comb, the stream of water then bends towards the comb, explaining this phenomena. And this concludes our video. We hope you've enjoyed it.